Hi everybody. So in this video, we're going to look at solving problems with probability distribution tables. We'll work through 4 questions, and if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So in our first question, we're told that the table below shows the probability distribution for a discrete random variable x. We've got our observed values here and the probability of our random variable equaling that observed value given here. And then we've been asked to work out a value of q. So we should know that the probabilities all add up to make 1. So we can work out q using the sum of the probabilities equaling 1. So 0.35 plus the 0.25 plus the q and the 0.14 and the 0.1 will all equal 1. Then we can add these decimals together and we get 0.84 plus q to make 1. So q will equal the 1 take away the 0.84, 0.16. Okay? I'll include this in our table. And then for part B, find the probability of a random variable being less than or equal to 2. Well, if it's less than or equal to 2, then the observed value could be equal to 0, or it could be equal to 1, or it could be equal to 2. But it can't be any more than that. So all we need to do is add these probabilities together. So we've got the 0.35 plus the 0.25 plus the 0.6. And when you add these together, we get 0.76. And then for part C, to find the probability of x being less than 4 but greater than 1, well, this is where x could be 2 or it could be 3. We know the probability of it being 2 is 0.16, and the probability of it being 3 is 0.14. So we'll add these together and we get 0.3. Okay? Let's try another question. Okay, so in this question, we're told that the discrete random variable x has this probability distribution, and the discrete random variable y has this probability distribution. It is claimed that the probability of x being greater than or equal to 3 is greater than the probability of y being less than 5. We've been asked to determine if this claim is correct. So perhaps you want to try this question yourself. Okay, so if we begin with the first statement, the probability of x being greater than or equal to 3. Well, this means it could be equal to 3, or it could be equal to 4, or it could be equal to 5. I'll change that to a plus. And then we can add each of these together. So we get 0.1 plus 0.15 plus the 0.25. And this gives us 0.5. So this is the probability of x being greater than or equal to 3. And then we need to find the probability of y being less than 5. But to work this out, we need to work out the value of p. And we know that all the probabilities will add to make 1. So we've got the p, add for 2p, so 3p. We can add these decimals together, and we get 0.76. And together they make 1. So 3p will equal 1. Take away the 0.76, which is 0.24. We'll divide both sides by 3, so p will equal 2/25. Okay? Or 0.08 when y is 2, and 0.16 when y is 4. So now the probability of y being less than 5, if I just move this down to here, we could add up the 2, the 3, and the 4, but it's easier to find the difference between 1 and the probability of y equaling 5 plus the probability of y equaling 6. So we've got 1 minus the 0.2 at the 0.26, and this will give us 0.54. So you can see that the probability of x being greater than or equal to 3 is less than the probability of y being less than 5. And therefore the claim is wrong. Okay, let's try another question. Okay, so in our third question, we're told that the discrete random variable y has this probability distribution, and that two values of y are chosen, y1 and y2. We've been asked to work out the probability of their product being greater than their sum. So if you want to try this question yourself, you can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So to work out these probabilities, we're going to need to create a sample space diagram. So if we look at the probability of y1 multiplied by y2, now we know when we multiply anything by 0, we'll get 0. So then when either y1 or y2 is 0, their product will always be less than their sum. So we don't need to include these zeros. So if we look at y1, we can have 1, 2, or 3. And then for y2, we can have the same. And then their product would be the 1 times the 1, the 1 times the 2, the 1 times the 3. Then we'll have 2, 4, and 6, 3, 6, and 9. Then if we compare this to y1 plus y2, we'll create another sample space diagram. So we'll have 1 at 1 is 2, 1 at 2 is 3, then we'll get 4, 3, 4, and 5, and 4, 5, or 6. So now we need to identify when the product is greater than the sum. So this will be when we've got a 2 and a 3. You can see the 6 is bigger than a 5, a 3 and a 2, or a 3 and a 3. Okay? You can see that this 9 is bigger than this 6. So we need to work out the probability of a 2 and a 3, or a 3 and a 2, or a 3 and a 3. So if we look at this one, a 2 and a 3 will be 0.45 multiplied by the 0.25. We can double that because this will be the same. And then we can add the probability of a 3 and a 3, which will be 0.25 multiplied by itself, so squared. When we work this out, we get 23 over 80. Okay? So this will be the probability that the product is greater than the sum. Let's try another question. Okay, so in our final question, we're given this probability mass function where d and m are constants, and we've been asked to work through paths A and B. So do you want to try this question yourself? You can pause the video and then come back when you're ready. Okay, so how did you get on? If we begin by drawing our distribution table, we've got the observed value y, and then the probability of our random variable equaling that observed value, and y ranges from 1, 2, 3, and 4. When y is 1, we're using dy, so this will just be d. When y is 2, we've got 2d. When y is 3, we've got 3 squared m, so 9m. When y is 4, we've got 4 squared m, so 16m. For part A, the probability of y being equal to 3 in terms of m, well, this will be this probability, 9m. Part B. We're given that the probability of y being greater than or equal to 3, which is when y equals 3, or when y equals 4. When y is 3, we've got 9n. When y is 4, we've got 16n. So together we've got 25n. And this will be equal to 4 times the probability of y equaling 1 or y equaling 2. So this will be equal to 4 lots of y equals 1, which is d, plus the 2d, so 3d, and this will equal 12d. To work out the values of m and d, we need to write d or m in terms of the other. So if I divide both sides by 12, then d will be 25m over 12. And then we can substitute this expression for d into our distribution table. So we've got 25m over 12. When we double this, we've got 25m over 6. And we know that all these probabilities add up to make 1. So we've got the 25m over 12 plus the 25m over 6 plus the 9m and the 16m all add to make 1. And when you add these together, we get 125m over 4 to make the 1. So m will be 4 over 125. And then we can use this value of m, we'll substitute it into here to work out d. So d will be 25 twelfths multiplied by 4 over 125. And this gives us 1/15. So this is our value of d here. Okay? Well, I hope that's given you an idea on how we can solve problems with discrete random variables. If you found that helpful, please like and subscribe, and you can download a full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.